Hi everyone and welcome back to the channel. Today we are discussing about the working principle of transistor derating. Imagine we are building a circuit and our transistor working perfectly at room temperature. But what happens when the things heats up? That's where the derating comes into the picture. So what exactly the transistor derating? It's the reduction in the transistor maximum power dissipation PD max as its operating temperature increases. Let's look at the basic transistor circuit. We have a base voltage VBB and the collector voltage VCC, and we are considered the NPN transistor for the discussion. The maximum power dissipation PD max is the maximum amount of the power the transistor can handle without being damaged, and it is calculated by multiplying the collector to emitter voltage VCE sat by the collector current IC stat. In our example, let's say our transistor has a PD max is equal to 2 watt at 25 degree centigrade, which is the room temperature. Now here is the key, the derating factor. This tells us how much that power dissipation decreases for every degree centigrade increases in temperature. In our case, it is 4 milliwatt per degree centigrade. That is derating factor. This means that every degree the temperature goes up, our transistor can handle 4 milliwatt of less power. And we will calculate the maximum power dissipation at 85 degree centigrade. That means the maximum temperature T max will be 85 degree centigrade. First we need to find the change in the power dissipation. That is delta PD max is equal to derating factor into change in the temperature. In our case, the derating factor will be 4 milliwatt per degree centigrade into 85 degree centigrade minus 25 degree centigrade, which is equal to 4 milliwatt per degree centigrade into 60 degree Celsius, which will give us 240 milliwatt. So the maximum power dissipation PD max at 85 degree centigrade equal to 2 watt minus 0.240 watt, which will give us 1.76 watt. This means that at 85 degrees Celsius, transistor can only safely dissipate 1.76 watts, not the original 2 watts. Ignoring derating can lead to overheating and premature failure of our transistor, which means our circuit won't work as expected. Let's do a couple of more quick examples, and in the example 2, we will consider maximum power dissipation PD max is equal to 200 milliwatt and VCE sat is equal to 15 volt, and we need to find the IC sat. And if you rearrange the previous equation, the IC sat is equal to maximum power dissipation divided by VCE sat, which is equal to 200 milliwatt divided by 15 volt, which will give us 13.33 milliamps. And let us consider another one example. Here maximum power dissipation PD max is equal to 5 watt and IC sat, the collector saturation current will be 50 milliamps, and we need to find the VCE sat value. So that VCE sat is equal to maximum power dissipation PD max divided by IC sat, which is equal to 5 watt divided by 50 milliamps, 100 volt. Understanding derating is essential for designing reliable electronic circuits. Always check the data sheet for your transistor derating factor and plan accordingly. I hope this video helped you to understand transistor derating. If you have any question, leave them in the comments below. Don't forget to like and subscribe for more electronics tutorial. Thank you. Thank you for the watching.